Welcome back to the session. Today's topic is sets. That is here 1C. For example, here I am having 1, 2, 3, 4, 5, 6, so on. That is here these are what? Natural numbers. These are what? Natural numbers. And one more example I am writing 1, 3, 5, 7, 9, so on. And A, E, I, O, U. That is 1C here. This is what? Natural numbers. And this is what? Odd numbers. And this is what here? These are called what? Ovals. That is here. This is what? Natural numbers. That is natural numbers are denoted by what? N. And 1, 3, 5, 7, 9. These are what? Odd numbers. That is O I am taking here. And next A, E, I, O, U. These are what? Ovals. That is V here. These all are what? These all are based on some property. That is, this is what here? Natural numbers from 1 to so on. That is up to infinity. And these are what? Odd numbers. And these are what? Vowels. Here for example I am having here even numbers set. That is E equals to 2, 4, 6, 8. Only I am writing here 2, 4, 6, 8. That is even numbers less than 10 or less than or equals to 8. This is called what? Even numbers set. And see next example, that is here. All the students in 10th class. All the students in 10th class. This is what? This is a set. And for example, here I am writing. That is here. Smart students in your class. Smart students in your class. Out of these two here, all the students in the 10th class. That is in your 10th class here. I am saying what? The number of students is becomes what? Set. And here I am saying what here? Smart students in your class. Here smart. The word is what here? Smart. That is, it is not what? Well defined. It is not well defined. It is not well defined. And here all the students means what here? This is what? Well defined. Well defined. That is here. A set is a well defined collection of objects. A set is a well defined collection of objects. A well defined collection of objects. And these objects are called what? Elements. These are called what? Elements of a set. Here 1, 2, 3, 4, 5, 6. And here 1, 3, 5, 7, 9. And here A, E, I, O, U. And here 2, 4, 6, 8. These all are called what here? Elements. Objects means here elements of a set. And for writing the elements of a set, here we are using what? Here braces. That is flower braces. And the elements are separated by what here? Commas. Elements are separated by commas. And this is what here? This is called what? Roster form. This is what? Roster form of a set. That is, if the set elements are written in the flower braces and these are separated by commas, then we say that these are in the roster form. And coming to the next one, that is what? Set builder form. Once here. Next one is set builder form. That is set builder form. One see here. Here I am writing. The elements are 1, 3, 5, 7, 9. These are what actually? These are odd numbers. These are odd numbers. Odd numbers up to which one here? Less than 10, or you can write this as what? Less than or equals to 9. For example, here I am writing x such that, that is here x such that is here x is an element in O. X is an element in O. That is x such that x is an odd number. X is an odd natural number or odd number less than 10. X such that x is an odd natural number less than 10. That is odd natural number means here odd numbers are what here? 1, 3, 5, 7, 9. Less than 10. That's why I am writing up to 9 only. That is here set builder form means what here? It is described by here set builder form is described by what here? This is called what? Property. X is an odd natural number less than 10. This is what? Property. It is described by some property. And which is what here? All the elements are based on this property only. That is, it is described by some property which is common to all the elements. Which is common to all the elements. Which is common to all the elements. It is described by some property which is common to all the elements. This is roster form. And this is what? Set builder form. That is here. The difference between these two is, in the roster form we are writing the elements directly. That is, we are writing the elements. And what about set builder form? In this case we are not writing the elements. Here we are writing what? Only the common property belongs to the elements. This is the difference between roster form and set builder form. See one more example based on this. That is here I am writing P equals to x such that x is an even prime. P equals to x such that x is an even prime. Okay, this is the set builder form. And what about roster form to this one? Roster form to this set. What is an even prime number? This is the common property. And which elements we are having in this set? That is here only the even prime is what? 2. Only 2. That is P is equals to what here? 2. This is an even prime number. In this way, based on the condition, we are writing elements in the roster form. Here next one is what? Types of sets. That is here we are having in this finite sets, infinite sets, null set, singleton set, equal sets, equivalent sets and subset. Okay, before going to discuss about this one, see once. For example, I am having A equals to 1, 4, 9, 16. 1, 4, 9, 16. That is here A equals to 1, 4, 9 and 16. In this set, how many elements we are having? That is once you count. Elements are 1, 4, 9, 16 and number of elements means here this is 1, first element, second, third, fourth. That is number of elements in the set A is equals to what? Number of elements in set A is equals to what here? 4. That is number of elements in set A equals to 4. That is in the sets it is denoted by here n of. N of means number of elements in set A. Here set is denoted by what? A. That is n of A is equals to 4. N of A is equals to 4. That is this is called cardinal number of a set. This is called cardinal number of a set. Cardinal number of a set. Cardinal number of a set means here the number of elements present in the set. The number of elements present in the set is called what? Cardinal number of a set. Here one more example. N equals to 1, 2, 3, so on 99. 99. That is what here. These are what? 1, 2, 3, 4, 5, 6, so on up to which number here? 99. That is natural numbers from 1 to 99. In this set, what is the cardinal number of this n? That is cardinal number of a set. Is what it is denoted by what here? N of. Here set is represented as capital N. That is n of n is equals to, in this set, how many elements we are having here? 99 elements. That is 99 elements. That is cardinal number of a set is what here? 99. That is here. If the number of elements are countable, that is here we are having what? 4 and here we are having what? 99. That is in this case the number of elements are what? Countable. That is if the number of elements are countable, then it is called what? Finite set. Then it is called what? Finite set. These are what? Finite sets. These are finite sets. Next, coming to the next one, see here one example. N equals to 1, 2, 3, 4, so on. That is, this is what? Natural number set. Natural number set means here up to what here? Up to any limitation is there? No, that is up to infinity. That is, these are countable or not? These are not countable. That is, infinite set means what? If the number of elements are uncountable, then it is called what? Infinite set. Finite set means the number of elements are countable. And infinite set means what? The number of elements are uncountable. Next, see here, null set. That is, here null set means what? Example, n equals to x such that x is a natural number. X is a natural number less than 1. Less than 1. Here the condition is what? X is an element and that element is what here? Natural number, and natural number, one more condition is what? Less than 1. Do you have any natural number less than 1? No, because natural numbers are starting from 1 only. That is, in this set what here? We don't have any elements based on this condition. Then in this case it is called what? Null set. This is number of elements is what here? 0. Number of elements is 0. That is n equals to, this is what? Set builder form. When we are writing the roster form here, this is what? Empty set. A set without any elements. A set without any elements is called what? Null set. And these null set we can represent it as empty braces or pi. This is what we call it as pi. Empty set or pi. That is empty braces or it pi. You can represent it as pi. This is null set. Here natural numbers is equals to x such that x is a natural number less than 1. And then what are the elements in this set here? This is actually null set. Null set means the number of elements in the null set is what here? N of, here it is what? N. Natural numbers means N of N. That is number of elements in this set is what here? 0. That is N of N is equals to what here? 0. That is always the number of elements in the null set means here 0. Next one is what? Singleton set. That is here singleton set means, for example, I am writing here A equals to P. And E equals to, I am writing some element here 3. P equals to X such that X is an even prime. X is an even prime. Once here, singleton statement, once you observe all these three here A equals to what? P, and E equals to what here? 3, and P equals to what here? X such that X is an even prime. Even prime means what is the element in this? That is roster form of this one is what here? Even prime is only 2. That is P is equals to what? Only the element is 2. Once you observe in all the sets here we are having how many elements here? Only one element. Only one element. That is the cardinal number of A of these sets is what here? What is N of A here? 1. And N of E equals to also 1. And N of P is equals to also 1. That is singleton set means here number of elements is only 1. A set is containing only one element, then it is called what? Singleton set. That is, a set is having only one element. A set is having only one element, then it is called what here? Singleton set. Next coming to equal sets. See, next one is equal sets. That is here A equals to A, B, C, D, and B equals to also I am taking A, B, C, D. Here set A is containing A, B, C, D elements, and set B is also containing what? A, B, C and D elements only. That is equal sets means here these are what? Elements. These are what? Elements. That is if the elements are same. If the elements are same in both sets. If the elements are same in both sets. That is both sets means here we are having what? A and B sets. If A and B are two sets and that sets are containing the same elements, then we say that A and B are what here? Equal sets. A and B are equal sets. A and B are equal sets. That is A equals to what here? B. That is the cardinal number is in these sets is what here? Same. That is N of A equals to 4 and N of B equals to also 4 here. The elements are same in both the sets, then we say that A and B are what? Equal sets. For example, one more example here. A equals to some red, green and pink, and here I am having one more set, that is S for example, and here I am having what? Green, red, pink. One see that what is the difference in these two sets here? A equals to what? Red, green and pink. And S equals to what? Green, red and pink. in A and S, that is the objects are same. The objects are same. Red, green, pink and green, red, pink. But only the difference is here, the order is different. The order is different. In these case also, A and S are what? Equal sets only. Because the sets are containing the same elements. That's why these are what? Equal sets only. Equivalent sets. That is here equivalent set means, see here, if A and B are two sets, and here in A set I am having 1, 2, 3, 4, and in B set I am having P, Q, R and S. P, Q, R and S. Here set A is containing which elements here? 1, 2, 3, 4. And set B is containing what? P, Q, R, S elements. That is in the previous, that is in equal sets. If the elements are same, then we say that the sets are equal. Here what you observe here? In set A, what is the cardinal number to this one? N of A. And here it is what? N of B. That is cardinal number of A set means what? Number of elements present in the set. That is number of elements are how many here? 4. That is N of A equals to 4. And here N of B equals to also what? 1, 2, 3 and 4. That is N of B equals to also 4. That is if the number of elements are same, then we say that the two sets are equivalent sets. That is N of A equals to what here? 4 and N of B equals to also 4. That is N of A equals to N of B. That is the number of, if A and B are two sets, if A comma B are two sets, if the number of elements are same, if the number of elements are same, then we say that what? A and B are which sets here? Equivalent sets. Then A and B are equivalent sets. Equivalent sets. That is, once see here. For example, I am taking here A equals to 1, 2, 3 and B equals to some 3, 4, 5 and 6. Here see, A equals to 1, 2, 3 and B equals to 3, 4, 5, 6. Here number of elements in set A equals to what here? 3. And the number of elements in set B equals to what here? 4 elements. Set B is having 4 elements. That is, the number of elements in set A and set B are not equal. That's why these are what? These are not equivalent sets. When the sets are equivalent sets, if A and B are two sets, if the number of elements in the both sets are equal, then we said these are what? Equivalent sets. This is the difference between equal sets and equivalent sets. And see, next coming to subset here. What is a subset? Next one is subset. That is here. One see one example. Here I am taking A equals to 1, 2, 3, 4, 5 and B equals to 1, 2, 3, 4, 5, 6, 7. That is here. In set A we are having what? 1, 2, 3, 4, 5 elements. and in set B we are having what? 1, 2, 3, 4, 5, 6, 7 elements. What you observed in these two sets here? Here if A and B are two sets, then here number of elements present in the set A, that is number of elements present in the set A are also in set B. Then we say that A is subset to B. That is here number of elements present in the set A are also in set B. Then we say that A is subset to B. This is the subset symbol. A is subset to B. See next example here. For example, A equals to here 2, 4 and 6. And B equals to 2, 3, 4, 5, 6, 7. Is it a subset or not? That is A is subset to B or not? That is A equals to 2, 4, 6. What is our condition here? If the number of elements present in the first set are also in the second set. That is which elements we are having in the set A. If that elements are also in set B, then we say that A is subset to B. Here 2, 4, 6 is in set A, and also in the same way 2, 4, 6 is also in set B. In this case A is subset to what? B only. That is A is subset to B. This is what? Subset symbol. And if it is here A equals to, I am writing 1, 2. And B equals to here 2, 3. 1 see. Here A equals to what? 1 and 2 are the elements. And B equals to what? 2 and 3 are the elements. In the second set we are having only 2. One element we are not having. That's why A is not subset to B. All the elements are not in set B. That's why A is not subset to B. How you represent this not subset here? Like this. This is not subset. And this is what here? Subset. This is what? Subset. A is not subset to B, and this is what? A is subset to B. In the same way, once you see here, in set A we are having what? A equals to 1, 2, 3, 4, 5. Here, see, 1 is in what? Set A. 2 is in set A. 3 is in set A. 4 is in set A, and 5 is also in set A. How you represent this here? 1 belongs to A. And 2 is belongs to A. And 3 is belongs to A. And 4 is belongs to A. And 5 is belongs to A. This is called what here? Belongs to. This is called belongs to. That is, if the elements are in these sets, then we said that is belongs to A. 1 is in set A, 2 is in set A, 3 is in set A, 4 is in set A, and 5 is in set A. Then how you say that here we are having only 5 elements. Then what about the element 6? 6 is in A or not? How you represent that? 6 is not an element in A. Then how you represent that? That is 6 is does not belongs to A. Does not belongs to A. This is the symbol we use for does not belongs to. Does not belongs to. This is belongs to, and this is does not belongs to. And see here, in this what here? A equals to 1, 2 and B equals to 2, 3. That is 1 is belongs to A and 2 is belongs to A. But 3 is what? Does not belongs to A. 3 is does not belongs to A. And also in the same way 1 is does not belongs to B. That is 1 is not an element in B here. And in the same way 3 is not an element in A. That's why 3 does not belongs to A and 1 does not belongs to B here. In this way you can describe the sets. That is what is a subset and which one is not a subset and which element is belongs to the particular set and so on.
If you want to continue with this channel, make sure you continue to subscribe and hit the bell icon. Thanks for watching this video. Bye bye.